Reliability centered maintenance. It's a RCM. There's a couple of formal terms for this, and those are SAE formats as JA1011 and JA1012. It was born from a study that Nolan and Heap did for the airline industry back in the day to allow the DC-10 planes to get off the ground. What it does is it's designed to bring in a cross-functional team and discuss all aspects of a system and create a maintenance plan that allows for the best management tools and mitigation strategies at that moment. So it's not a once and done thing. It's not an end all be all either. And it's a very in-depth analysis. If you're using real reliability centered maintenance or RCM analyses, it takes a minute. It's labor intensive and it's very thorough. Over the years, there's been a lot of different methodologies that have come up and things that have changed in order to utilize RCM in a more streamlined fashion. And those are the key aspects of that are the failure modes and effects analysis, or FMEAs. In an application, practical application, you have a certain percentage of your equipment that's going to be run to failure because it's cheaper to let it fail and replace it than it is to actually do anything to schedule maintenance against it or perform an assessment against an FMEA or an RCM. And then there's going to be a large proponent of your assets that are going to get like an RCM, right? It'll be, or not an RCM, but an FMEA. And it'll take less time. You'll get through it. You'll probably get 90% of the actual failure modes with some reasonable and accountable processes. And then about 10% of your assets, or maybe even less, because they're mission critical, they're safety critical, or they're environmentally critical, that are going to get an RCM because they have to be broken apart into the finite little minuscule details of all the things that could and will fail and what the probabilities are of those failures. So one of the things besides a good asset hierarchy and a good bill of materials for your assets and drawings that you need to do an RCM, you need to have some people that could be engineers, some equipment people that are from maybe a vendor or supplier, an operator, maintenance supervisor, operations supervisor. These particular people and these roles are going to have hands-on, invaluable information around their practical experience. And then whoever facilitates this is going to have to be able to pull out what the function is. So what did I buy this piece of equipment to do? By the book. What was it intended? What was its intended use? And then there's going to be primary and secondary functions. When you start to talk about an RCM, in an FMEA, you want the primary functions. You want to get as many of the secondary functions as you can, but you're going to group a few of those things together because it does save time. And then we're going to go through and figure out in what ways that things can fail to meet their functions. So whatever I've listed as their functions, in what ways do they fail to meet those, right? So if they fail to meet their function, what does that mean? Is it totally failed, functional failure? We have to define those things. And then the failure modes. What actually caused the functional failures? What effects did it have on the machine? And then in an RCM, you take it one step past, and even an FMEA, but it's not quite as in depth. But the step past that is, what are my maintenance strategies? Am I going to let it run to failure? Am I going to do a periodic change out or a periodic rebuild? Or am I going to find some way to condition monitor this? Whether it's a predictive tool, whether it's an AI tool, whether it's an IoT tool, or if I'm just going to do a visual inspection. And if the cost or the consequence of failure is too high, then I may need to opt to re-engineer or redesign something to be able to maintain it so that I mitigate that failure. Some of the keys for that, again, the time, the data, the people, and the ability to update and put this into your maintenance management system so that you can monitor. And I'm going to say a good rule of thumb for RCM to be able to have it maintain its validity is that every 18 months an RCM should be reevaluated, and every 12 months an FMEA should be reevaluated. It doesn't mean redo it all. It means take the work order history that you have and the failure data that you have and compare it against the failure modes you identified in those analyses, and had put in the PM program or the PDM program to validate whether or not you're still seeing those failure modes, you've mitigated them, or if there's new ones that nobody thought of when you did the review meetings that need to be added to, so you can enhance and again elongate the life and the value of the RCM that you did. It's a very valuable tool. It will honestly make a huge difference when it comes to preventing things, and it will also help provide a basis for new equipment design because of the failure modes that you found that were relevant to your specific operating context. I told you, there's actually this particular topic. There's actually a 3-day course for this, just for the people that would participate in the analysis. And an analysis takes a month to do on an asset, on a system. And the first week is the facilitator just going around and collecting all that information I was just telling you about. And then the next 2 weeks is working with a review group to identify the functions, the functional failures, the failure modes, the failure effects, and what the mitigation strategies are going to be, including the periodicity, how frequently you're going to do them, and who's going to do them. And then past that is the job plan writing, and then you hand it off to somebody to actually load into, create or update all the PMs in the system, and then turn the wheel on the first 2 or 3 of those you do. And that's why you don't do it for every asset. You do an RCM on like your top 10%, maybe even your top 5%. And then the rest you'll do an FMEA for. And then, so that'll be 10%. The FMEA is probably another 60%. And the last 30, they just run them to failure. On purpose. There's no scheduled maintenance. So they'll install it with precision, but they won't, you deliberately say, like when you're doing an RCM, okay, I'm going to do vibration analysis on this thing monthly. What's that cost? Well, it's $275 a data point per analysis. So I'm going to spend $1,250 a year to do predictive maintenance on this asset. And then you look at it and go, well, what happens when it fails? When it fails, this tank fills up and it'll set off an alarm. Okay, but it won't shut anything off. Nope. Okay, so what does it cost to replace the pump and the motor, the little combination thing when it fails? Oh, it's $350. And how long does it take for you guys to change it out? It'll take us like an hour and a half, maybe. I said, so your labor rate fully loaded is $60 an hour. So you're talking about $90 plus the $700 for the part with no impact to any. When you do this, you're not really shutting the plant down, correct? And they're like, oh no, you don't shut it down. You've got 3 hours of runtime in the tank if they fill it all the way up, and then we can valve it off and change it. All right, so no impact to operations. The cost to let it just fail and respond to it, as long as you have one on the shelf, is an hour and a half. So the total overall cost to let it run to failure is $875. And you're telling me it's better for you to spend $1,250 a year to let it do the same thing. That's RCM in a nutshell, right? And then there's criticality analysis, which talks about the probability of failure. What are the consequences? If this thing fails, is it production, quality, cost, safety, or environmental? What's the consequence of the failure? And you score those, you weight those, right? And then you say, okay, so with that, what's the probability that failure is going to occur? Is it 1 in 10, 1 in 100, 1 in 1,000, 1 in 500,000, 1 in a million? And if it's that, is that tolerable? So if somebody could die, doesn't matter if it's 1 in 5 million, I'm going to do something to monitor the situation at some interval so that I prevent somebody from dying. The same thing with an environmental release. It all becomes risk-based maintenance at that point, but nobody likes to use that term anymore because there's a lot of connotations with OSHA and NFPA and a few other things. If you start doing that, they can come back and say, well, you didn't have these things taken care of, and why aren't your logs updated, this, that, and the other. So yeah, there's that. And there's a cost to doing this. You usually hire somebody who's a third party to facilitate these things.